Okay, this is lesson 5.2, Trigonometric Special Angles. In this lesson, we're going to work with the special angles of 0, 30, 45, 60, and 90. And these are very commonly used angles in trigonometry, and so common, in fact, that we can determine the exact value of sine, cos, tan, and even our secondary trig ratios of these special angles, and then use those exact values to do precise calculations in math rather than having to get decimals and work with decimals. We want to be able to work with exact values. And where the ratios for these come from are first, the 45s and the 90s come from an isosceles right triangle, and I'll show you that triangle in a second. And then the 30, 60, and 90 come from a right triangle as part of an equilateral triangle. So to set this up, I'm going to use two diagrams and show you where these angles would be in these diagrams and how we could find the ratios more exactly. So the first one is just a square. And if we call it a unit square, which means that all the sides of the square are the same, and let's actually say all of the sides of the square are 1. 1, 1, 1, 1. That would be the simplest square that we could work with. If we draw a diagonal across it, it splits the square into two triangles. In this triangle, it would have a right angle where two of the sides would be 1 and 1, and the third side would be the hypotenuse. And if we wanted to find that hypotenuse, we could with Pythagorean theorem. A squared plus b squared equals c squared. A and b are 1 and 1, so 1 squared plus 1 squared would equal c squared. 1 squared is 1, 1 squared is 1, 1 plus 1 is 2, so c squared is 2. And if we square root both sides, we get c is the square root of 2. And since we want to work with exact value, we actually leave it as the square root of 2. So now what we have is well, a right triangle, and we know three sides. In fact, we actually know the other two angles too. Since all of the corners or all of the angles in a square would be 90, if we split it in half with a diagonal, these angles are 45 degrees. And what that allows us to do is, well, it allows us to find a bunch of trig ratios, because now we have a triangle that we know three sides of and two of the angles. In fact, the angles are 45. So from the angle 45, we could find sine, cos, or tan, or even the secondary trig ratios. But let's do sine for an example. If we wanted to know what sine 45 is, we would do opposite over hypotenuse, or 1 over root 2. And 1 over root 2 would be the exact value of sine of 45. We could do cos of 45 too. It would also be 1 over root 2 because the adjacent side would be 1. The hypotenuse would be root 2. There's 1 over root 2 again. And if we want to do tan 45 would be opposite over adjacent, which would be 1 over 1, which is 1. So now you can now find the exact values of sine, cos, and tan of 45 degrees using this 45, 45, 90 triangle. This is a special triangle, and this special triangle is something that you will be given on all of your tests. So if you need to find sine, cos, or tan of 45, you would just look at the triangle and do opposite over hypotenuse for sine, opposite over adjacent for cos, or opposite over adjacent for tan, or adjacent over hypotenuse for cos. Might have messed one of those up, but you get what I'm saying, I hope. The 30, 60, 90 right triangle, we can make an equilateral triangle where all three sides are the same. And this time I'm going to call the sides 2, and I'll show you why in a second. 2, 2, and 2. And the reason I'm going to use 2 is because I'm actually going to split this triangle down the middle and turn it into a right triangle where this side would be 1. And the reason I made them 2 is because when I split it, I wanted it to be a nice simple number like 1. We can find the other two angles in this triangle as well, because in an equilateral triangle, all three angles would be 60 degrees. We split this angle, We split it directly in half because it's an equilateral triangle. So we know that this angle would be 30 degrees. And this angle was not split. It was part of the original triangle, so it's 60 degrees. And now we have a triangle where we know two sides. We know 2 and 1. We don't know this side. So again, we can use Pythagorean theorem. We'll call this side A. So A squared plus B squared equals C squared. This time we know B and C. B would be 1, and C would be 2. And we don't know A. So if we do a little bit of math, we get 4, 1, A squared. Move the 1 over, we'd subtract 1, we get 3. So A squared is 3. If we square root, we get that A is the square root of 3. So now we know this side. And now we have a triangle with 30 and 60 in it. So we could use this triangle to find sine, cos, or tan of 30 or 60. If we wanted sine of 30, we would do opposite over hypotenuse and get 1 over 2. If we wanted sine of 60, we would do opposite over hypotenuse and get root 3 over 2. This triangle is very useful because we can get two angles out of it. Now, if you want to know sine, cos, or tan of 0 or 90 or 180 or 360, anything that goes up in increments of 90, to get the exact value of that one, you actually just type it into your calculator and you'll either get answers of 0, 1, or undefined. And the reason why you get 0, 1, or undefined, we investigate later in this unit. It actually might be next unit. Later in next unit. But for now, if you want 0, 90, 180, 270, or 360 of sine, cos, tan, or any of the special trig ratios, you can get that one directly in your calculator. The 30, the 45, and the 60, though, are going to come from these two special triangles, which you'll be given. Now, I have another way to get the trig ratios as well, and this one's using your hand. You will not be given a picture of your hand on your formula sheet. However, if you remember it, you can definitely use your hand to do it. The way it works is you label your fingers with 0, 30, 45, 60, and 90. On your palm, you write root over 2. Sine goes this way, cos goes this way. So we're going to do two examples using the hand and the special triangles and show you that you get the same answer. So the way the hand works is you flip down the finger that corresponds to the angle you want. The number of fingers to the left gives you the numerator of the sine ratio. So it would go here. The number of fingers to the right would give you the numerator for cosine ratio. So what do I mean by that? Well, let's do sine and cosine of 30 degrees. Sine 30, we're going to have an answer in the form of root something over 2. And cos 30, we're also going to have the answer of root something over 2. To find out what, we're going to put down this finger because we know we're looking for angle 30. So I'm going to cover it up with my pen. The number of fingers that are still up to the left tell you what the numerator on sine is. So for sine 30, the number of fingers that are still up is 1. So sine 30 is root 1 over 2, which can be simplified because the square root of 1 is 1 over 2. Cosine, if we cover up 30, we'd have 3 fingers up to the right. So it would be root 3 over 2. Let's go check these using our special triangles. We want sine and cos of 30, so we're going to go look at the special triangle with 30 in it. 30. And we want sine 30. Sine 30 would be opposite over hypotenuse. 1 over root 2. That one checks out. Cosine 30 would be adjacent over hypotenuse, which would be root 3 over 2. That one checks out as well. So you can either use your hand or the special triangles. There's an advantage and disadvantage to both. The advantage of using the special triangles are that you'll be given them on the test. So you'll have them to use. The hand you won't be given on the test. So there's an obvious advantage to using the tool you're going to get on the test. The advantage of using the hand trick is the denominator will always be in the form of 2. There will never be a radical in the denominator, so you'll never have to rationalize your answer. And that's something that we had to do in previous units. And that happens when you get a root in the denominator. For example, say we were working in this triangle, and I wanted to do tan 30. Tan 30 would be opposite over adjacent, 1 over root 3. We'd get a root 3 in the denominator. We can't have a root 3 in the denominator, so we'd have to simplify by multiplying top and bottom by root 3. You'll never have to do that when you're working with the hand trick. The other disadvantage to the hand trick is it only works for sine and cos. So working for sine and cos, you could also find the secondary ones for cosecant and secant by flipping the sine and cos ratio. But the tan one you can't get from your hand. You can get it from the special triangles. So how do you get the tan one if you're using the hand trick? Well, what I'm going to have you do after this lesson is complete this summary chart. But I'll show you the tan one. So we just did sine and cos. So I'm going to fill in sine theta or sine 30 was 1 over 2. And cos 30 was root 3 over 2. What if we wanted tan 30? Well, we could use a special triangle. Or this property, tan, is actually just sine divided by cos. So if you want tan 30, you would take your answer for sine 30 and cos 30 and divide them. The reason why this works, well, this is called a trig identity, and it's something we're actually going to prove in a future lesson. But to show you the math behind it, tan 30 would be 1 over 2 sine 30 divided by root 3 over 2. How do you divide fractions? You flip the bottom one and multiply. 1 over 2 times 2 over root 3. What happens when you multiply across? Well, the 2's would divide away, and we'd be left with 1 over root 3, which is a little bit of a problem because we have a root on the bottom. So we would multiply the top and bottom by root 3, and we'd end up with root 3 over 3, tan 30. So tan 30 is root 3 over 3. If we use the special triangle, tan 30 would be opposite 1 over adjacent root 3, 1 over root 3, which is exactly what we got from dividing sine and cos. We just need to rationalize the denominator. How do you get cosecant, secant, and cotan? You flip these three. Flip sine to get cosecant, you get 2. Flip secant, flip cos to get secant, you get 2 over root 3. But the problem is we get a root 3 on the bottom, so we have to multiply the top and bottom by root 3 to get rid of the root 3. And we're left with 3 on the bottom and 2 root 3 on the top. And to get cotan, we flip this one, but that one's tricky to flip. It's actually easier if you flip this one. 1 over root 3 would give you root 3 over 1. If you flip this one, you get 3 over root 3, and then you can divide top and bottom by root 3 to end up with root 3. These are the exact values for 30. I want you to figure out the exact values for 0, 45, 60, and 90. Zeros, you'll use your calculator. 45 and 60, you'll either use the hand trick or you'll use the special triangles. And 90, you'll use your calculator. So try to complete that table on your own, and then make sure to watch part 2 of our lesson. Thanks for watching, and I'll see you next time.